This lecture is on polygons, regular polygons, convex, concave, different ways of classifying polygons and angles associated with them. So first of all, what is a polygon? Well, let's look at some different types and then come up with a definition. This is a polygon, so yes. This one would also be a polygon, that shape. This is not a polygon. This is a polygon. This is not a polygon, and this one is not a polygon either. So what we need to have is straight sides, ruling out this one here. We need to have an enclosed region, which rules out this one here, and only one enclosed region, which would rule out this one over here. So note that this is actually a polygon, and let's take a look at that now, after we take one more look at the definition. So we have convex versus concave. This is a convex polygon. This is a concave polygon. Now, a rough way of noticing the difference is that concave, you can say it's sort of caved in, but if you imagine drawing diagonals, all the different diagonals you can draw, all the diagonals in a convex polygon are inside the polygon, whereas for a concave polygon, you have some exterior diagonals. That's one way of being more exact about it geometrically as to how you identify between convex and concave. Now we're only going to be dealing with the convex, just this type over here. So now let's take a look at the interior angles of a convex polygon. And then what we look at is this. We have 5 sides, and you just pick any one vertex and you draw the diagonals just from that one vertex. So I have these 2 diagonals. And if you have 5 sides, you're going to end up with 3 triangles. Now each one of those triangles is 180 degrees, so the total interior angles in this polygon is 540. So if you add up all of the angles, you get 540. That is, imagine removing these, just add up all the red angles, you get 540. Let's try this again. So in this case, we have 7 sides. And so when we go ahead and draw diagonals from any one of the vertices, we end up with 5 different triangles, 1, 2, 3, 4, 5. So it's subtracting 2 is what happens. And so the total interior is going to be the number of triangles, which is 7 minus 2 times 180, because each triangle is 180 degrees, and we get 900 degrees total. And so from this, we can basically derive this general formula that the total interior degrees for any convex polygon is going to be the number of sides minus 2 times 180. Okay, now as far as some classifications. If you have a triangle, it's got 3 sides, quadrilaterals 4, pentagons 5, hexagons 6, a heptagon, not a septagon, is 7, heptagon, octagon 8, nonagon 9, decagon 10. Sometimes we say 12 for dodecagon. For any number n sides, you say n-gon, and if it's not one of these numbers, we say 11-gon, for instance, if it's 11 sides, or say a 40-sided polygon would be a 40-gon. You don't say 40-agon, it's 40-gon. So it doesn't fall into one of these categories. You put the number and then gon. So you have to be able to understand the numbers as well. And so here we see the list again, along with some applications on the side. Okay, exterior angles. Now for exterior angles, imagine we have this polygon here. The exterior angles are given by extending the sides. So this angle plus this angle plus this angle plus this angle plus this angle. And what I've done is I've now taken this exact same shape and I've made it smaller. So we have this angle, this angle, this angle, this angle, and this angle. But you would agree that if we make it smaller, it doesn't change the sum of the angles. And then I just shrink it all the way down to a point. So it's a very tiny pentagon. And so what happens is now when you add them all up, it's like adding up all the angles in a circle. And so the total exterior degrees, no matter how many sides you have, is always 360 degrees. It doesn't make any difference how many sides you have. It's always 360. Okay, so now getting into specifically regular polygons. A regular polygon is that one in which all the sides are congruent and all the angles are congruent. So for a regular one, since all the angles are congruent, we can talk about just one individual angle. Well, this is a pentagon, and so it's going to have 5 sides, so the total interior degrees will be 5 minus 2 times 180. So if you just want to get one of the interiors, you do 5 minus 2 times 180, which was 540, divided by the number of angles, which is 5, and you come up with 108 degrees for each one. So you take the total interior divided by the number of sides. So your formula for this would be total interior, that's the formula we saw a little while ago, n minus 2 times 180, number of sides minus 2 times 180, divided by the number of angles, which is the same as the number of sides you have. So this is now the formula for one regular interior angle of a regular polygon. One interior angle of a regular polygon. Now instead, if we look at an exterior, we can say that since we know the sum of the exterior angles is always 360, and since all of these would be congruent, we simply take the total again and we divide by the number of sides. So it's the same idea for finding one exterior as it is to finding one interior. You take the total and divide by the number of sides. In this case, the total is 360 divided by n. Another thing to note is that an interior and an exterior will always add to 180 because they're supplementary, as you see there. And we can actually derive that. This is the formula for one interior of a regular polygon. This is one exterior, and if you multiply everything by n, then these will cancel. I can distribute the 180, and then I cancel 360s. If I multiply n to this side, I get 180n, and you see that this formula works. So these will also be supplementary. Okay, so then just to sum up the formulas here, we have for n sides, so we've got n equals n, then the number of triangles we have inside when we draw our diagonals is n minus 2. Sum of all the interior angles, n minus 2 times 180. Exteriors will always be 360 regardless of the number of sides. One interior, n minus 2 times 180 over n. One exterior, 360 over n. And those only work for regular polygons, so those angles are congruent. So as we see, one interior regular, one exterior regular are supplementary, and here again is a proof of that, similar to the one that I showed a moment ago. Okay, a little practice with these formulas. So we want to find each of the variables. This is three sides. It's a regular polygon. We're told each is a regular polygon. And so to find an exterior angle, it's 360 over 3. So this is going to be 120 degrees for x. To find y, well, it's 3 minus 2 times 180 divided by 3, because there's three sides. So that's 180 divided by 3 gives you 60 degrees. Over here we have n is equal to 5, so to find a is going to be 5 minus 2 times 180 over 5, which will equal 108. And then to find, well, let's make sure of that. I think it's 144. Yeah, it's 3 times 180 is 540 over 5. Oh no, that's 108. Okay, and then to get b, we can do 360 divided by 5, which is 72. And notice these are supplementary. Okay, we want to find the missing angle measure. We've got 1, 2, 3, 4, 5, 6 sides. So the total interior is 6 minus 2 times 180, which is 4 times 180, which is 720 degrees. So I can say that 124 plus 150 plus 93 plus 130 plus 90, because of that right angle, plus x will all equal 720. And then you've got to do the arithmetic and subtract all that stuff from 120. Same idea down here. We've got 1, 2, 3, 4, 5, 6, 7 sides. So 7 minus 2 times 180, which is 900. So we add up all of these guys plus x and set it equal to 900, and then subtract them all off of 900 to get x. Okay, here we have 12-sided polygon. So n is equal to 12. Find one exterior angle, so 360 over 12 is equal to 30 degrees. An interior angle, we can use our formula, n minus 2 times 180 over n, and plug in 12, but it's easier just to realize that these are going to be supplementary, and if we do 180 minus 30, we get 150 degrees. That's a faster way to go. Okay, these problems are using formulas, but from a different point of view. We're given the measure of an interior angle and find how many sides. So we set 120 equal to n minus 2 times 180 over n. I'll multiply n to the other side, so 120n, and I'll distribute the 180. 180n minus 360. Add 360, subtract 120n, and then divide by 60, so n is equal to 6. So this would be a hexagon that would have an interior angle of that. I'll do this one a little differently. If this is an interior angle, we know the exterior angle is supplementary. So the exterior is 72, and I set that to 360 over n because that's one exterior angle. And then I can flip these guys, so n is 360 over 72, which is equal to 5. So this would be a pentagon that has that interior angle, regular pentagon.